Hello and welcome back to Physics for the 21st Century. My name is Greg Perugini and we will be covering friction today. Now friction is a force. It's only present in opposition to other forces. For instance, if I have a box that I'm trying to push on in this direction, without friction, in order to get it to accelerate from 0, I need a force equal F, force equal ma. But friction is opposing me. In this case, the friction's static because it's standing still. Once it starts to move, there's a frictional force kinetic. And each of those have their own coefficient of friction. Now, as I said, friction is an opposing force. It is opposing this. If the frictional force is greater, you can calculate the frictional force as being greater than the force that I'm pressing. Obviously, the box is not going to move. But that doesn't mean that if the force, in fact, it is greater, it is up to that point. Follow? The box is not going to, if there is a greater frictional force in opposition, it will go up to the opposition. Obviously, it doesn't make sense for, if this is greater, for this to move in that other direction. How is it calculated? Well, first of all, again, it's a vector. And we could treat it like any other vector, just like we did with force in the previous lecture. And in fact, yes, it is force. So we can have F equal ma, and also that it is equal to a coefficient of friction, we'll talk about what that is, times the normal. The normal is a perpendicular to the surface. Okay, I should draw it like this: perpendicular to the surface opposing another force. In this case, the force is gravity down, negative. So what we have as an example here is a positive normal force. It isn't going through the table, this box. So we would multiply that by the coefficient of friction. The normal can be against any force, including gravity. If I threw something up against a wall, for instance, the wall is going to oppose that force. That is what the normal is. So, as we've defined the normal force, it can be set against any force, including gravity, as we have in this case. So what is that coefficient of friction? Well, it depends on the surface. It depends if we're talking about static, kinetic, or rolling. Static is the force, is the coefficient for those particular two materials that keep it stationary. Kinetic is moving, and if I have an object that's rolling, I would use the coefficient of rolling. In this little table, you could see some examples, and there are thousands of examples. You can see that Teflon on Teflon has a very low static and coefficient of kinetic friction. Let's look at an example here. So I'll make this screen bigger again. I have a ball that's rolling. Okay. And the ball is rolling on a surface. And this surface, we're going to just say is sticky. How am I going to define sticky, right? We'll get to that. But we know it's a 5-meter long surface. And it's rolling in this direction. And it hits this. And its initial speed when it hits this point is 7 meters per second. The coefficient of static friction between the ball and this sticky surface is 0.24. Or excuse me, in my example, it should be 4.3. It's quite sticky standing still. In rolling, 0.24. So let's look at that carefully. And after it goes through this, this is the before position. And then it rolls, and after it's through that sticky surface, this is the after position. What's its speed here? How do we calculate that? Well, look at that carefully. Maybe take a few minutes to think it through. But we do know that the force of rolling friction, MA, coefficient of rolling friction times the normal, which is equal to, in this case, the normal is going against gravity. Gravity is coming down at mg, so the normal going up is positive mg. Well, if MA is equal to U rolling times mg, well, you look here that the m's cancel out. And I can get the deceleration of this, the force that is decelerating it, the force of rolling friction that is decelerating it. I can get that deceleration by multiplying the coefficient of rolling friction, which is 0.24, times gravity, 9.8. And I'm going to get 2.4 meters per second squared. Decelerating. It is opposing whatever force that had that going. Well, given that, and knowing that I know, well, now I know acceleration is equal to negative 2.4. And I know the change of distance is 5 meters. And a velocity initial is equal to 7. Well, we've solved enough using friction and the opposing force of friction that we have this information that we know, and we can use the kinematics. I'll throw the kinematics up there once again. I'm sure you're sick of them by now, but the only one we're going to need is that one again. So what we find is we want velocity final squared is equal to velocity initial squared okay, times 2 times negative 2.4 times 5. So whatever that is, take the square root and you're going to get the velocity final squared. I'll leave that to you to get that answer. I wrote that a little bit high, so let me rewrite that again. We're using, notice we're not using the static friction. This is moving. So we're going to use this equation again. And in summary, velocity final squared is equal to 7 squared plus 2 times negative 2.4 times 5. That is going to give us our final velocity once we take the root of this. And I'll let you solve for that. So, in summary, since friction is an opposing force, it can go up to that opposing force but not over it. You can see the nonsensical things that would happen if I'm pressing against an item and I can't move it because it has more frictional force holding it in place. Well, if it has more frictional force potential, maybe is a better word for it. If it was actually more frictional force, the minute I pressed on it, it would have more. It would go in the opposite direction. That would not make sense. It can go up to the opposing force, but not over it. As a force, we still need to use the kinematics here and solve for acceleration in and all directions. So you see how I use that in this particular equation here, right? Because the force of friction is a force, and it still follows ma. And in terms of fighting against gravity, we're doing rolling friction mg. It is opposing the negative result of gravity downward. So there you have it. That's pretty much all you need for friction. To know that it opposes a force, and this friction can also be a number such as drag, air friction, for instance. We're talking about friction between two surfaces. But frictional force is an opposing force. And good luck.